Hey kids, Smath here. Final video on acid base. This is about titrations. Now, titration is a process basically where you're going to determine the concentration of something. But before we get there, we need to go through and look at acid base reactions just a little bit over here. What we have are things called neutralization reactions. And that's going to be a double replacement reaction that's between an acid and a base. Now, we defined 2 videos ago, acids are going to start with H, bases are going to end with OH. And when we run a double replacement with that H and OH are going to go together and form water. And what's going to be left over from the anions and cations that were used is some generic form of a salt. So let's take a look at a couple of examples. We're going to take sulfurous acid, not sulfuric, sulfurous, H2SO3, and we're going to react that with potassium hydroxide, KOH. Now, that's going to combine, and I'm going to edit here a little bit. So the H is going to combine with the OH, and the K is going to combine with the SO3. When that H and OH combine, they make HOH. That's the same as water, right? We said that back in January when we did reactions. And then the K is going to go together with the SO4. Now this is +1 and this is -2. So we're going to bring that 2 on down to make it K2SO4. And then to get it to balance, because we have 2 potassiums right here, we're going to bring a 2 outside, and that's going to give me 2 hydroxides to work with my 2 hydrogens over here from my acid, and I'm going to make 2 waters. And that's a neutralization reaction. We've taken the acidity from the acid, the basicity from the base, and what we've done is brought their pHs down together to become a neutral solution, neutralization. Let's take a look at another one. Calcium hydroxide and phosphoric acid are going to combine. And so we're going to take the OH here and the H there, and we're going to make waters. And you can already see we're making 6 of them. And you ask, why do we make 6? Well, look, there are 3 hydrogens and 2 hydroxides. So the least common denominator of 3 and 2 would be to make 6 waters. And when we do that, the calcium ends up needing 3. And we ask, well, why is that 3 there? That 3 is there because phosphate, remember, was a -3 and calcium was a +2. So that 3 comes down and that 2 comes down. And so to get that to balance, we're going to have to put a 2 out in front of the acid and a 3 out in front of the base, and everybody would be happy. Now, these neutralization reactions are used in a process called titration. A titration is a process. It's a laboratory experiment where we're going to use a known concentration, also known as the standard solution, okay, to determine the concentration of something that's unknown to us. And so in that case, we're going to find an unknown concentration. That's what we're looking for, okay? And one of the ways we're going to know that we've solved this is we're going to look for this thing called an endpoint. And endpoints are changes in color because we added a substance called an indicator. Now, indicators are things like phenolphthalein. You may have heard of that one before. It's a chemical which, when the pH changes, the color of the solution will change. And I'm hoping to get a video here to show you some indicator color changes. They're really quite pretty and kind of cool to watch as they occur. So we're going to set up our titration experiment here with a little flask. And that flask has an acid in it with some sort of indicator. Just a drop or 2 of indicators, all we need to get a color change. Up top, we have a big long burette. Burettes are used because they're very, very accurate, usually to the 100th or 1000th of a milliliter. And in that burette is called a titrant. That's the substance that we know the concentration of. Down here in the flask, that's our unknown. That's the unknown concentration. What we do know is we know the volume of our acid. And that's kind of helpful. The titration calc couldn't be easier. All we're going to do is take the molarity of the acid times the volume of the acid equal to the molarity of the base times the volume of the base. Okay, here's a sample problem I've got for you. Back to a little handwritten. Calculate the molarity of HCl when 20 mils of HCl is titrated with 16.6 of 0.30. So the molarity of the acid is what we're looking for. The volume of the acid is 20 mils. That can be in milliliters or liters as long as the base is in the same unit. The base is 30 molar and the volume 16.67 mils. So we added 16.67 mils of base until our solution changed color with our indicator. Okay, and if we calculate this out, the molarity of our acid is 0.25 molar. As I say, the calculation couldn't be easier. So that's the setup of titrations as well as the calculation for titrations. I've got a worksheet or two for you to work on with these, but they're really M of A, V of A, M of B, V of B. I am Smath, and I hope this video helped.